Okay, let's make a little math video here. If you missed class, we did these 4 setups in class on a white piece of paper, and then the homework is a similar problem on a yellow piece of paper. So let's dive in here. We want to find the area contained by these curves and rotate it around the x-axis. So let's see, first here we need a root of x going from 0 to 3. The root of 0 is 0. The root of 1 is 1. The root of 3 is a little bit less than 2. So here is our curve. Boom. And we're going to rotate around the x-axis. I got my red spinny arrow over here. So here is my representative rectangle. The first thing we always ask ourselves is this disk method or washer method. And our bottom of our rectangle is always in contact with the axis of rotation. So this is going to be the disk method. So we're perpendicular to x, so everything is going to come from the x-axis. I'm going to put my integral symbol here. I'm going to get my pi out front. My lower bound comes from the x-axis 0. My upper bound from the x-axis 3. So since we know this is disk method, we want to put the height of the rectangle in here and square it. So the height of the rectangle is what's touching the top of the rectangle. That would be the root of x, minus what's touching the bottom of the rectangle, which would be 0. So I'm not even going to write in the minus 0. So here's our setup. The root of x, quantity squared, that's just going to make the radical disappear. All right, and we don't have to solve this all the way. The point of the video is just to show you the setup and figure out what method is at use here. So I hope on your own you could antiderive that to x squared over 2 and then evaluate it from 0 to 3 and multiply by pi at the end. So that was part A, x-axis rotation. In part B, all of this stays exactly the same, but now we're rotating around the y-axis. So we are rotating around the y-axis, so I am going to draw a representative rectangle that is perpendicular to the y-axis. We are going to need to solve this equation. Right now we've got y equals. We're going to need to solve for x equals. So we're going to square both sides, and x equals y squared. So that function is x equals y squared. So let's do our setup. We've got our pi out front. We are going now, our numbers are going to come from the y-axis. We're going to go from y is 0 to the square root of 3. 0 to root 3. Now, is this disk or washer method? Our axis of rotation is the y-axis. The bottom of our rectangle is only going to touch the axis of rotation at the origin. Other than that, there is a gap between the bottom of our rectangle and our axis of rotation. So this is going to be washer method. Washer. So we need an outer radius that we're going to square. The outer radius is the farthest from the axis of rotation. So here's my axis of rotation. The farthest my rectangle ever will be away from that is right here at that consistent line of 3. So that's our outer radius, 3. Now minus, we need our inner radius, also quantity squared. The inner radius is the one closest to the axis of rotation. So right here on our representative rectangle, the left side of it, that is the closer one to the axis of rotation, and that is touching the curve, y squared. So we're going to have our pi integrate from 0 to root 3. 3 squared is 9, minus y squared squared is y to the 4th. So there's our setup. We would just antiderive each of these terms and then evaluate from 0 to the root of 3. Okay, we've done X and Y axis rotations. Now let's change it up. We're going to rotate around X is 3. And if we look at our picture here, it's the same plane region, but now we're rotating around this red vertical line going through 3. And I'm going to draw my representative rectangle in there perpendicular to the axis of rotation. We are also perpendicular to the Y axis. So we're going to have the same pi, and we're going to integrate from the same 0 to root 3. Ooh, that's an ugly 3. That's a little bit better. Let's go back to the picture. Here is our axis of rotation, and the rectangle is touching it all the way across. So this is going to be disk method. Disk method. So what we want to put in here is the length of our rectangle, and we're going to square that, and we're going to have a dy. Now this is a little trickier because we are not rotating around the x or the y axis. So here's my thought process on that. If I'm down here, the longest my rectangle can ever be, or the farthest I can ever be from my axis of rotation, is this point right here, and that is 3 units away from my axis of rotation. So we're going to have 3 minus. And then we're going to plug in the function y squared. Now, I do like to check a couple of these, especially at the extremes. If I put in y is 0, I would get 3 minus 0 squared. That's equal to 3. And when y is 0, my rectangle here would be 3 units long. Let's plug in a 1. 3 minus 1 squared is 3 minus 1, or 3 minus 1, 2. At y is 1, this rectangle would be 2 units long. And then our other extreme, our point right here, is root 3. So if I make y into root 3, I'm going to have 3 minus the root of 3 squared. And that's going to be 3 minus 3, or 0. When I get to this point right here, I have 0 length of my rectangle remaining. So there's our setup. And before we move on, I'm just going to do one thing. We've got our pi, 0 to root 3. If I was to FOIL this out, because it is quantity squared, I would have 9 minus 6y squared plus y to the 4th. So then you would antiderive each term separately and evaluate it first at root 3 and then again at 0. All right, last one. We are now going to rotate around the line x equals 6. So red line here vertically going through 6. So we're going to be perpendicular to our axis of rotation. We are also perpendicular to our y-axis. That's our axis of integration. So once again, we're going to have a pi, and we're going to integrate from 0 to root 3. Now, axis of rotation is over here. Rectangle's over here. We are not at any point touching our axis of rotation, so this is going to be washer method. So we're going to need an outer radius that we're going to square. Oops. Outer radius squared. This is kind of similar to what we saw in the last one. You know, the outer radius is what is the farthest we can ever be from our axis of rotation. So if we go from that red line at 6, this point right here at the origin is the farthest we can ever be away. That is 6 units away. And then we're going to minus our function, the same y squared. So let's plug in a few y values, and this should give us the length of this rectangle here as it moves through this region. If I make y into 0, I'm going to get 6 minus 0 squared, and that is 6 units away. That's how far away, from our axis of rotation to this end of the rectangle is 6 units away. If we go up to y is 1, that's right there. So if I make this 1 or y into a 1, I'm going to have 6 minus 1 squared. 6 minus 1 is 5. We are 5 units away from the axis of rotation. Now let's plug in the extreme root 3. If I do 6 minus root of 3 quantity squared, that's going to be 6 minus 3, and we would be 3 units away from our axis of rotation. So this is our outer radius, quantity squared. Now our inner radius, also quantity squared. This is a little easier. Here is our inner radius, and that is consistently 3 units away from the axis of rotation. Boom. So let's do a little bit of algebra with this. Whoa. I've got my pi. Integrate 0 to root 3. When we FOIL this out, that's going to be 36 minus 12y squared plus y to the 4th. And then this is going to give us a minus 3 squared is 9. So then we can do the 36 minus 9. We can just replace this with a 25. And then we're ready to start integrating and evaluating. So I hope these 4 setups were helpful for the graded worksheet. Again, that should be on some color paper. Here in 2026, I printed it on yellow.